Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to do the derivation of magnetic field on the axis of a circular coil. Okay, because this derivation important in a CBSE board exam also. Now after completing this derivation we will see some special cases, graph, B versus X graph, and after that we will solve some 3-4 questions of NEET and JEE exam. Okay, so let's start the video. So here we can see under the topic magnetic field on the axis of a circular loop. Okay, so the diagram you can see very well. There is the one circular loop is there in a which plane? YZ plane, like this. Now let's take this is the x-axis, y-axis towards you, z-axis is there. Now so one circular loop is there in a which plane? YZ plane. Okay, and here the radius of the circular loop is the capital R, and its center is coinciding with the origin O, and the current, as I have told you very well, the current is like this. That means in a screen, upward current is coming towards you and downward current is going away from you, like this. Now this is towards you, this is away from you, like this, is it? And after that there is the one observation point P is there on the x-axis, and its distance, that means the distance of observation point from the origin, or we can tell center of the ring, how much is there? X is there, is it? So P is the observation point, I is the electric current, capital R is the radius, and small x, as I have told you, center to the observation point distance, is it? And most important, the ring in a which plane? YZ plane, and observation point is where? On the x-axis, is it? So now let's see all this description and all, because in our derivation we have to write all these things. Now so see here, let a circular loop of radius R carrying current I is placed in YZ plane with the center at origin O. Now after that, see, magnetic field due to current element IDL. Now it is a vector quantity actually. So magnetic field due to current element IDL at point P on the axis of loop at a distance small x from the center O of the loop is given by. So here what is happening, that here in this circular loop so many small current elements are there. Na? Because if you draw tangent at any point of the loop, you will get the current element. That means we can tell infinite number of current elements are there, is it? So because of this infinite number of current elements, we have to calculate magnetic field at point B, is it? So when we have to add magnetic field due to all the infinite current elements, what we have to do? We have to do the integration, is it? And to do the integration we have to make one formula, then only we will integrate. So to make the formula we will take two current elements symmetrical because observation point at P. So we will take two current elements symmetrical with respect to x-axis. Okay, with respect to those two current elements we will calculate the magnetic field at point P. Then after that we will integrate that formula, whatever we will get, by taking these two current elements, and then we'll get the answer here. Okay, so let's see here. So let's see students here, current is flowing like this, is it? So let's take one current element I have taken, that is coming towards you. That means that is along which direction? Z direction, is it? So you can take very well, this is the current element. This current element should be parallel to Z axis here, is it? This Z axis and this is here. This current element is what? Let's take here IDL. This current element is what? IDL. Now symmetrical to this current element, downward also we will take one current element, but this will be along which direction? Along negative Z direction. That means opposite to Z axis. That means anyhow, okay, I'll try to do it here. Now like this is there. This is the current element opposite to Z axis, and this is also current element is what? Ideal. This current element, like this, see, this current element is towards you. This current element is downward, inside the screen, away from you. So these two current elements we have taken. Now due to these two current elements we have to calculate magnetic field at point P. Okay, so to calculate the magnetic field at point P we will use here Biot-Savart law. Okay, so we can write here according to Biot-Savart law. So see here, we will write here, see, according to Biot-Savart law, because this is the application of Biot-Savart law. Okay, according to Biot-Savart's law. Okay, so what is the formula? The magnetic field formula due to any current element is given by mu naught by 4 pi I dl sin theta by r square. Okay, r is the distance from current element to the observation point. Is it? R is the distance from current element to the observation point. Theta is the angle between current element and the position vector. Okay, and this mu naught by 4 pi, remember that this mu naught by 4 pi value is 10 to the power minus 7 in SI unit, and mu naught by 4 pi value is 1 in CGS unit, that I have discussed in the previous videos. So now what I will do here, I will take here this one, position vector, na, or we can tell current element to the observation point. See, this I am going to do here. See here. No, wait, I will take here some different color. Is it? Because anyhow this is there. Na? Let me take some different color. So no, current element to the position, current element to the observation point. This I have taken here. Na? Here also I will take here. See, for this also let me take here like this here. See, okay, like this I have taken. Na? So let me write here. See, this is the R, na, current element to the observation point. Is it? After that, what is happening that here? See, this is also R is there, na, just like a cone. So now what we are going to do, we have to write the magnetic field at point P due to this current element ideal. Is it? So after that, what will happen that here, we have to get here the directions actually. Okay, so how to get the directions? See here, students, the this is the current element towards you, na, and you think here, if in case my position vector is like this, na, position vector is like this. So if I will use even Fleming's right hand rule or the magnetic force formula, na, by the curl, so we have to curl our finger from ideal to the position vector. Now see, we have to, if I write Biot-Savart law in a vector form, mu naught by 4 pi I dl cross r cap by r square. Na? So I have to curl my finger through the smaller angle, na, right hand. So see, like this. If in case this position vector is horizontal, this is ideal, this is B. So see, the magnetic field will go upward. But you see, this position vector is horizontal. No, this is somewhat tilted. Na? So when it will tilt, because of this tilt, what will happen? That the magnetic field will be like this, somewhat inclined. That means perpendicular to both ideal and this position vector r, position r. Is it? So because of this ideal, what we know, the magnetic field will be in which direction? Perpendicular to both of them. And remember that here like this here, by Biot-Savart law. Is it? Like this I can write here. Okay, very very important. Now like this. See, it is not going properly, but okay, anyhow, like this here. Now this one will tell here the dB. Okay, and this angle how much here? This angle is 90 degree. Is it? This angle is 90 degree. This one we have got here now, and similarly symmetric to this. Now here you see the current element is inside, and if the position vector is like this, you know what will happen? Ideal cross r will be downward, but this position vector is somewhat tilted. So ideal cross r will be somewhat like this, inclined. Is it? So here what will happen that here? If I write here, just let me remove this point P. Is it? So here if I write here, this one here, see like this, it will be the position vector. Very symmetric it should be, okay, like this. And here also, this angle will be how much here? This angle will be also 90 degree, is it? So, these two things we have got is here, is it? This dB is coming because of this one, and this dB is coming because of this current element here, is it? I hope so. This is very very clear to you. See, I am putting here, see, this is the red color, so this dB because of this. If I write here, let's take here blue color, so see here, this ideal and this dB is there. Is it? Now I hope so. This is very very clear to you. Is it? Now after that here, what is this value of dB? You know very well here. See, if I talk about this, ideal is here and the position vector is like this. Na? So you can see how much angle is there? 90 degree angle is there. See, like this. Here angle is 90 degree. Similarly, if you see here, this is inside and this is the position vector like this. Here also you can see how much angle is there? 90 degree angle is there. Is it? Is it? Is it? See here. No? So here theta is how much here? In both this situation, theta is 90 degree. So if I write here the magnetic field due to current element ideal, what is the magnetic field formula? It will come here. See, this dB equal to mu naught by 4 pi I dl sine ideal sine how much? 90 degree here. How to represent the 90 degree here? See, 90 degrees like this. Whenever we have to write the 90 degree, now see, 90 degrees here. Here also, if I want to represent the 90 degree like this, see, this is the 90 degree. Okay. So ideal sine 90 degree by r square here. And sine 90 how much here? 1 only. So we can write mu naught by 4 pi I dl by r square here. Is it? Kindly make it here equation 1. Is it? Now after that, what we have to do? We have to resolve here the components. Is it? So see, if I resolve here the components here, Okay, so let's take here, for example, if this angle is alpha. How much angle? Alpha. Anyhow, see, this is 90 only. This is also 90 only. Is it? This angle is alpha. So what will happen that here? This side component will be what here? See here? This side component will be dB cos alpha. Is it? And due to this dB also, if this angle is also alpha, so due to this dB also, component will be dB cos alpha. Is it? So even I can write here comma and see here dB cos alpha. Is it? This dB cos alpha because of this dB cos alpha because of this. Is it? So 2 dB cos alpha components are there. After that, if I take here the vertical component, see, like this. Now, like a parallelogram. Like a parallelogram here. Is it? Let me draw here the line. See, it is not coming. See, I'll take here the some line like this, so that we can draw properly. Let me draw like, no. We should draw here the dotted line. Is it? So that we can get it properly. Now, just I am trying to make it as much a good way as possible. Is it? So let's take like this here. No? So see, this is one component. This is what? This is dB sin alpha. Here also one component will go downward here. No? Parallelogram, like a full parallelogram. Okay, like this. Parallelogram should be there. No? Parallelogram. What is this? This is also dB sin alpha. Is it? dB sin alpha. Now what will happen that here, the students, you think here which component will cancel out here? Which component will cancel out? You can see very well. This dB sin alpha, that means due to this current element, is cancelled by dB sin alpha, no? Of this component. That means dB sin alpha components, dB sin alpha vertical components of this current element and this current element will cancel out. And what will happen that here? This horizontal components will add up. Is it? So you have seen that due to these 2 current elements, we have got the 2 horizontal components dB cos alpha. Like that, if we see infinite number of components are there, na, because current element on the circular loop, so many current elements are there like a tangent. Is it? So what will happen? So many infinite number of dB cos alpha will be there, na, that we have to add. All in which direction? Horizontal direction. Okay, x direction. Similarly, so many dB sin alpha will be there that will be parallel to the yz plane. All this dB sin alpha, that means parallel to yz plane, what will happen? They all will cancel out. Is it? Very, very clear. That means you will see that here when all this dB cos alpha is going to add up, remember that here the resultant magnetic field will be in this direction. What is this? In this direction we will get here the resultant magnetic field BP. Okay, the resultant magnetic field at point P will be in which direction? Horizontal direction, because all these components we had to add here. Is it? This is P. Okay, and after that one more thing is there. Let's take this angle is theta, this angle is also theta. Okay, so one more thing I will use here that will be required. So theta plus 90 plus alpha. See here, theta plus 90 plus alpha. How much here? This is 180 degrees. So alpha will be how much here? This alpha will be 90 minus theta. Okay, this thing is also required here. Na? Can you see very well? Now what we are going to do? We are just going to add this dB cos alpha components here. Okay, so let's see what is given here. It is given here, see, as point P is symmetric with respect to the coil, na? Because coil in a yz plane, point P on x-axis, vertical components of magnetic field, that is dB cos alpha. dB cos alpha, huh? See here, I think mistake happened. What happened? dB sin alpha will cancel out here. Okay, here instead of dB cos alpha, what is this? dB sin alpha. Okay, dB sin alpha will cancel out, but horizontal components of the magnetic field, that is dB cos alpha. Okay, dB cos alpha will add up as shown in diagram. Okay, so dB sin alpha cancelled out and dB cos alpha will add up. Is it? Now after that here, if I write here the resultant magnetic field here, now hence resultant magnetic field. Okay, resultant magnetic field. We'll write here resultant magnetic field at point P is given by, okay, like this we have to write. At point P is given by, what we can write here? This BP is a integration of this dB cos alpha. Na? So many dB cos alpha is there. Now after that here, what is the value of the dB? We know very well from the equation 1, mu naught by 4 pi I dl by r square here. Is it? After that, what is the alpha? Alpha we know 90 minus theta. Is it? So it will become here cos 90 minus theta. Is it? And after that, you know, cos 90 minus theta is the sin theta. Now if we talk about here, what are the components will constant? Mu naught by 4 pi is constant. The constant will come outside, so mu naught by 4 pi. And here this I is constant, and you know very well, each and every current element and the observation point is equidistant. How much distance from all the sides? R. So R is also constant here. And this cos 90 minus theta means sin theta here, is it? And cos 90 minus theta sin theta. And why? This theta will be also constant. Why? Because each and every current element will make how much angle at point P? That means position vector, this R, will make how much angle from the x-axis? Always theta. Okay. So this theta will be also constant. So cos 90 minus theta sin theta, it will cancel out. And this is the closed loop. One closed ring is there. So even I can write like this also. And here what will come here? Closed integration dl, because this circular loop is the closed here. Now after that here, what will happen that here? Kindly see, it will become here mu naught by 4 pi into I by r square into sin theta value. Now if you see even triangle, this triangle, if I talk about here this triangle, sin theta means what will happen that here? Perpendicular by hypotenuse. So my perpendicular is what? This, see, r. This perpendicular is what? This perpendicular is the r, is it? See, this r. And hypotenuse is small r, capital R by small r here. Okay. So what can I write here? Here I can write here capital R by small r. And tell me please, what is this close integration dl? So see, this circular loop is there, all this small dl. If we add, what this will become? We'll get the total length of the circle, and that will be what? That will be the circumference here. Okay. So it will come here 2 pi r here. Is it? See, circumference 2 pi r. Now after that here, what are the things will cancel out? Will cancel out here. See, this pi cancel. Okay. From this 2 to 4. Is it? So after that, what we can write here? We can write here, see, this BP is given by this mu naught. Now mu naught is there, IR square. Okay. Mu naught I square by 2. And here you can see very well, this R into R square, it will become here R cube. Is it? So mu naught IR square by 2 R cube. This thing we have got here, again. See. Again, if I use here the Pythagoras theorem, see here. Small r is what here? See, this is the one triangle, this is small r, this is capital R, and here anyhow x is there. So if you use here the Pythagoras theorem, it will come here hypotenuse square equal to base square plus perpendicular square. Is it? That means I can write here, see, from Pythagoras theorem, what we can write here? R square equal to x square plus capital R square. Is it? Or we can write here small r equal to x square plus capital R square power 1 by 2. Is it? This value I will put there. So what this will come here? It will come here magnetic field at point P is given by mu naught I r square by 2. R means we can write here, see, x square plus r square. Half is there, but here cube is also there. So it will become here 3 by 2. What this will become here? It will become here 3 by 2. Okay. So this is the formula is there. Students have to remember that here. And this formula is due to how many terms here? This formula is due to one term. Now only one term is there, then only. Okay. Similarly, if I write here, similarly if, or again we can write here again for n turns of coil. For n turns of coil of radius r. Each and every turn is having how much radius? R. Then for n turns of coil, you know what will happen that here? This BP will become here, remember that here, mu naught NIR square by 2 times x square plus r square power 3 by 2. This is for what? This is due to n turns here. Okay, this is due to n turns is there. So remember that here. So I hope so students, this derivation is very clear to you, important for the exam. Now students, after that here, if we see some cases, so some cases are here, see, magnetic field at different positions on axis. So see, at center or nearby points of the coil. So at center or nearby points of the coil, center means anyhow x is 0, but nearby points means also approximately 0. Why we are telling here? When observation point is at the center. See, this observation point P is there. When this observation point we are taking at the center. So see, the value of x is keep on decreasing. Here x will be how much here? 0. Is it? So what will happen here? In this formula, or okay, in this formula I will put x equal to 0. Okay. So when I will put x equal to 0, remember that here this BP, see here, the formula is what? Mu naught Ni r square by 2 x square plus r square power 3 by 2. Now, in this formula, what I am doing here, I am putting x equal to 0. That means we are getting at origin or nearby origin. So here it will come here what? Mu naught Ni by 2r here, is it? This is the magnetic field at the center of the coil. Even that we have done derivation also. Okay. After that, see the second one. At far distance away from the coil. At far distance away from the coil. That means what will happen that here? This x is greater than r. So when this x is greater than r, you know what will happen that here, students? When x is greater than r, this x square plus r square. Okay. Approximately we can just write here x square. Is it? And now you know in the formula 3 by 2 is there, is it? So here also we will write here 3 by 2. Here also I will write here 3 by 2. So anyhow this 2 and 2 will cancel. What this will come here? It will come here x cube, is it? That means in this formula, see the formula is this one here. Now, this formula we are using. Okay. So in this formula what will happen that here, see this BP will become here. See here mu naught Ni r square, is it? And this will become here 2. And this term will become what here? You know very well, x cube, is it? So this is the thing, BP equal to mu naught Ni r square by 2x cube. After that, one more thing is there actually we can do. If in case we multiply by pi and we divide by pi, for example, because one more thing we'll get here. So see, we can write here, see, mu naught by 2 pi, is it? Mu naught by, okay, 2 pi, okay, or we can see we are multiplying with the 2 pi, now 2 pi. So what this will happen that here, remember that here, see, it will become here, 1 minute. So 2 into 2 in a denominator, what this will become here, see, this 2 and this 2, see, mu naught by 4 pi, okay, because mu naught by 4 pi, we know the 10 power minus 7 into, here it will become here, see, 2Nia by x cube here. What this will become here, students, this formula will get here. What is A? Remember that here. What is A here, students? Remember that this A is the area of the coil. Pi r square. What is A? A is the area of the coil. Because radius is A na, so that one is there. Is it area of the coil? Because sometimes they may ask here. What they may ask here? They may ask at very far distance, magnetic field is directly proportional to area of the coil also. Okay. And what is A? Pi r square. Is it? So now, students, after that, next one, if we draw here the B versus X graph. So see here, if I will draw here the B versus X graph, in this, let me just take here, no, see, B versus X graph we are going to draw here, see here, just let me take here, see, this is I have taken, now this is the B horizontal, is it, just let me somewhat less, and after that, see, let's take, I have drawn the line, this is there, okay, so see here, anyhow this is not working out, see here, I draw like this even, okay, see, this is, see here. Now okay. Now okay. Now this is O, this is B. So you know very well here, students here. Now at the center, how much is there? This one here, mu naught Ni by 2r. And when what will happen? That when you will go away, what will happen? When this x will increase, when you are going away, this x will increase and this magnetic field will decrease. Okay. So remember that here the graph used to be like this. Okay, and here also you can write here like this, somewhat symmetric. Okay, symmetric graph used to be there. This and this side will be somewhat symmetric. Okay, let me draw here symmetric as it is as possible. Now, kindly draw here the symmetric graph. And here what is this? This is the B naught. What is this? This is the B versus X graph. Maybe sometimes they may ask, is it? And here away distance means what is this? This B is inversely proportional to X cube. This side also B inversely proportional to X cube here. Okay, remember that here. Is it? Great. Now, students, after that, we are going to solve here the questions. So, see what is the question. Question came in a NEET 2024. Even same question came in a NEET 2022 also. So, see here. The tightly wound 100-ton coils of radius 10 cm carries a current of 7 ampere. The magnitude of magnetic field at the center of the coil is how much here? Okay. So, first we'll note down the data is this. So, N how much is given here? N is given here 100. Okay. Radius of the coil, that means capital R is given here 10 centimeter. 10 centimeter, that means 10 into 10 to the power minus 2 meter, or we can write 10 to the power minus 1 meter. Is it? And current how much is given here? Current is given here 7 ampere. Okay. And they are asking the magnitude of the magnetic field at the center. Is it? So, students, you know very well here. What is the magnitude of the magnetic field at the center formula, see here, mu naught Ni by 2r here, is it? What is the mu naught value? You know very well, 4 pi into 10 to the power minus 7, is it? And how much is given here? 100, so we can write here 10 to the power 2. Current is given here what? 7, is it? And 2r, that means 2 into capital R value. How much is given here, students? You know very well, capital R is 10 to the power minus 1, is it? Capital R is 10 to the power minus 1. So from here, students, when we will simplify this and all, what will come here? See, this is 2, 2 2 is 4, is it? And after that here, see, let me write here, this is 2 pi means 22 by 7, and this 7 is also, all the numbers I have collected together. If I collect the powers, this minus 1 will go up, so 10 power 3 and minus 7, it will come 10 to the power minus 4. Again simplify this here, students. This 7 and this 7 cancel, so it will come here 44 into 10 to the power minus 4 Tesla. Or we can write here, see, 4.4 into 10 to the power minus 3 Tesla, correct? That means it will become here 4.4 millitesla, 4.4 millitesla. Which option is correct here? You can see the correct option is here, option C. Is it? See, this formula based question, mu naught Ni by 2r. Is it? Great. Now students, let's come to the next question here. The question came in a NEET 2022. See the question. The magnetic field on the axis, see the magnet, they told on the axis of a circular loop of a radius 100 centimeter. No? I'll write here itself 100 centimeter. Radius how much is there? 100 centimeter, 1 meter. Carrying current root 2 ampere. Okay, current is also given here root 2 ampere. Okay. At point 1 meter away from the center of the loop is given by how much here? Okay. And how much distance is going away? It is given here, x is 1 meter. And they are asking the magnetic field. Is it? So again, students, we know the formula. No? What is the formula? Formula should be remembered. Nothing is mentioned means how many turns? Nothing is mentioned means how many turns? The turns is 1 if nothing is mentioned here. Okay. So BP equal to what we can write here? Mu naught I r square by 2 x square plus r square power 3 by 2. Is it? So we'll write here mu naught value, how much is this? See, 4 pi into 10 to the power minus 7. Okay. And kindly see here, what is the value of the I? I is given here, students, root 2. I how much is given here, students? I is given root 2. Okay. And again r square means capital R. See, this is a radius, we'll write here the capital R. Okay. Capital R how much is given here? Kindly see here, 1 square. Okay. And see, 2, and here it will come here, x means, x is also 1. So 1 square plus 1 square and power 3 by 2. Is it? So students, what this will become here? We can write here, see, 4 pi into 10 to the power minus 7 into root 2 by here what will come here? See, 2 into 1 square plus 1 square, 2. 2 to the power 3 by 2. What will come here? 2 to the power 3 by 2. It will become here 2 root 2. Is it? 2 to the power 3 by 2. How much here? 2 root 2. Is it? So kindly see here. This root 2 and this root 2 anyhow cancel. No? This 2 and this 4 is also cancel. So what we can write here, students, it will come here pi into 10 to the power minus 7 Tesla. Pi value 3.14. Is it? So which option is correct here? The correct option is here. Option B is the answer. And radius is here capital R. Is it? Great. Great. Now students, let's move to this question. What is the question? Came in a JEE 2023. Okay. In 2023, one question, same kind of question they ask as a NAT, and in another like one in Jan month, one April month. In Jan month they ask as a MCQ, April month they ask as a NAT. Na? But basic was same. The ratio of magnetic field at the center of a current carrying coil of radius small r. See here. The radius capital R, the radius is given here small r, to the magnetic field at a distance small r from the center of coil. Okay. So small x how much is given? That is also small r. On its axis is root x is to 1. The value of x is how much here? So capital R is also small r, x is also small r. This thing is given. Okay. So what will happen that here? Kindly see here. As they are asking center, B naught by BP. B naught by BP, center to the axis. So B naught how much is there? See here, mu naught I by, first I will write here the formula. Mu naught I by 2r. Here formula, see, mu naught I square by 2 times x square plus r square power 3 by 2. Is it? This is the formula. After that here, see, I'll write here, see, mu naught I by 2. What is the capital R value? Small r here, is it? So I'll write here small r into, this will become reverse. Okay, so let me write here, see, mu naught I, what is the capital R value? Anyhow, r square. Now, so see, mu naught I small r square, and here 2, and this will become here r square plus r. See, x is smaller, capital R is also smaller, so r square plus r square, how much is coming here? 2r square power 3 by 2. Is it? Now let's see what are the things we'll cancel out. First we'll cancel the thing. See, mu naught I cancel, mu naught I cancel. This 2 cancel, this 2 cancel. Is it? That means what we can write here? Here it is coming here. See, 1 by r into, what this will come here? See, this will come 2 to the power 3 by 2 into r square power 3 by 2. So r cube, and here by r square. So again, students, what will cancel out? See, this r square, and this r cube cancel. So what is coming? 2 to the power 3 by 2. That means we can write here 2 cube power half by 1. So we can write here root 8. Now 2 cube means 8, 1 by 2 means 8. So root 8 by 1. Is it? This thing we have to compare with which one here? Root x by 1. Is it? So what is the value of the x? You can see very well. The value of x is how much here? 8. Now we have just calculated here the ratio. Is it? Great. Now students, just we are going to the last question. The question is what? See, came in a JEE 2021. Very good question. That's why I have taken here. So see, the fractional change in the magnetic field intensity at a distance small r from center on the axis of current carrying coil. Okay, so see, they have given here on the axis, x is given small r. Okay, from center on the axis of current carrying coil of radius a, to the magnetic field intensity at the center of the same coil is how much here? Okay, so here x is given r, radius is given a. Okay, this thing is given here, and one more thing is given here. What here, students? Here, this r is less than a. What is given here? See, this r is less than a, or we can tell this point P is very, very close to the center, or we can tell here this one here, x, this one here, this thing is done. No? So from there we can tell. So see the students here what will happen that here, if I'll just take here, first in the question they are talking about the axis, then they are talking about the center, and they are asking what? They are asking here the fractional change. Okay, so remember that here the students, this fractional change. What is this here, students? Fractional change. Percentage change means whatever we will get, we have to multiply with the 100. So fractional change means, see, Bp minus B naught by B naught. Why I am writing Bp minus B naught? Why I am not writing B naught minus Bp? But first, because first they told axis, then they told about the center. So Bp minus B naught by B naught. So what this will become here? It will become here Bp by B naught minus 1. Is it? Bp by B naught minus 1. Again, let me write here the formula and also see. First, let me write here the formula. Mu naught I r square by 2 x square plus r square power 3 by 2. Is it? By B naught means what is coming here? Mu naught by 2r here. Is it? And after that, just let me rough this here. No? And here what is this? This minus 1 is there. Okay. This minus 1 is separate here. See here, this minus 1 is separate, not in a numerator. Okay. So after that, students, what will come here? See, mu naught I. Okay. See, mu naught I is there now. First, let's see here what are the things we can cancel. Now we will just cancel here. Okay, but okay, let me write here, no problem here. Now, so see here, what is coming here, the students? See, mu naught I, and here capital R value how much is given? See, capital R is given a square. Have to be very, very careful. Mu naught I a square by 2. X value how much is given here? X value is the small r. Don't be confused. There small r was current element to the observation point, but here this x value is small r here. Okay, so 2 we can write as c r square plus capital R is how much given here? Again a. Have to be very, very careful. Okay, power 3 by 2 into this will become reverse, so we can write here 2 capital R is how much here? Capital R is a. So 2a by mu naught I, and here minus 1 is there. Okay, so now let's see what are the things we can cancel here, students. See, this mu naught I, this mu naught I is cancelled. Okay, after that, see here, this 2 and this 2 is also cancelled. Now other things will be pending. Now, so in the numerator what is pending? A square into a cube. Downward this is pending, and minus 1. Now can you see here? Okay, fractional change we are calculating here. Okay. So now students, what will happen that here, if I am calculating here the fractional change, that means BP by B naught minus 1, what is coming here, A square into A cube, is it? And let's see backside here, this one here, R square plus A square, see here, R square plus A square power 3 by 2 minus 1, is it? After that, see here, I can write here A cube, okay. And let's say the students, if I take here A square outside, so when I will take A square outside, it will become A square power 3 by 2, okay. And when I have taken A square outside, what this will become here, remember that here, this will become here, see, R square by A square plus 1, okay, minus 1. Now because A square I have taken outside, so what this will become here, see, A cube, here A cube, and here what this is becoming here, students, see, 3 by 2 is there here, okay, 3 by 2 is there here, R square by A square plus 1 power 3 by 2 minus 1 is there. Now this A cube is also cancelled, okay. Now you know that here, students, as R is less than A, R is less than A, we can use the binomial expansion here, okay. So even if I write here, see, we can write here, see, 1 plus R square by A square, because R square by A square plus 1 means we can write 1 plus R square by A square power minus 3 by 2 minus 1, is it? This thing is okay. After that, what will become here, see, this thing we are calculating, fractional change, BP by B naught minus 1, minus 3 by 2 will come here front left, okay. So what this will come here, 1 plus C minus 3 by 2 into R square by A square minus 1, is it? Then this plus 1 minus 1 is cancelled, that means what will come here, it will come here, see the students here, minus 3 by 2 R square by A square. Why this is coming minus 3 by 2? This is coming minus 3 by 2 because anyhow BP is less than B naught. This BP is less than B naught. So this term is less than 1. So less than 1 minus 1 means anyhow negative will come. So if I just take the magnitude, this fractional change will come what here? 3 by 2 R square by A square. Fractional change how much here? 3 by 2 R square by A square. So where it is that? 3 by 2 R square by A square, option D is there. Kindly see, very well, fractional change came in the JEE 2021. So students, I hope so this video in which we have done the derivation of magnetic field on the axis of the coil, important for the board exam, and this questions of NEET and JEE exam. Is it, students? So keep studying, keep going.